So in this video we'll be learning binomial distribution. So this is Numpy tutorial number 20. Now what is binomial distribution and how to get binomial data distribution using Numpy built-in function, that is binomial. So first explore binomial and what type of parameters stack it. So binomial distribution is a discrete distribution. What is discrete distribution? Discrete is defined at a separate set of events, such as a coin toss result is discrete as it can be only head or tail. On the other hand, the height of people is continuous as it can be 170 or 170.1 or 170.11 and so on. So binomial distribution describes the outcome of binary scenarios such as toss of a coin. It will either be head or tails. While using binomial function of Numpy library, you must have to use these three argument or parameter: and p size. N will be the number of trials that you want from that data, and p will be the probability of occurrence of each trial for toss of a coin, and it will be 0.5 for each. And the size will be the shape of the returned array. So you can also check here discrete distribution. So what is binomial distribution? It is the distribution of discrete data. Okay, so example, given 10 trials for coin toss, generate 10 data points. So first thing first, from numpy import random. Okay, and after that I'll be saying that x will be equal to let's say random dot by tab, and it will automatically suggest binomial. Okay, you can type it binomial. Now within this binomial it will take 3 n, p and size. N will be the trial, and as the question said 10 trials, so we'll be passing here 10, and p will be the probability, and it will be 0.5 for each, and the size will be your data points, and the question said generate 10 data points, so it will be set 10. What will happen if you just print x and enter? So we got this 5 5 6 3 5 6 at 5 4 4. So these 10 trials, these are the 10 trials out of 10 data points, and it's randomly generated binomial data distribution 2 times 5, after that 6 and 3, and third time 5, and 2 time again 6, and first time 8, and again third time 5, and 2 times 4. So in that way it will give you the binomial data distribution while using this binomial function. One thing that you have to remember is while using this binomial distribution, you must have the knowledge that n will be your number of trials that you want, and p will be the data probability for each, and that will be 0.5, and the size will be your data or distribution or points or whatever you call it. Now it's time to visualize binomial distribution. So for that I will again use from numpy import random and import matplot. Okay, plot tab, plot lib. Okay, dot py, plot is plt. After that we will import another library, that is cbon as sns. And if you have no idea about matplotlib and cbon, then you don't need to worry about it. Skip this part, just focus on binomial distribution. Matplotlib and cbon are both libraries used for visualization of your data. Okay, they do nothing, they provide some graphs. Okay, statistical graphs. Now after importing all these libraries, what we'll be doing, we'll be saying that print, not print, I'll be using here sns dot, and this sns has a graph, that is this plot. Now within this plot I will get my binomial data distribution. For that I'll be using a random dot binom tab, and within this I'll pass 10 trials. You can use n equal to 10, but I'll be using direct value, and now my trial will be 10. My probability for each will be 0.5, and I want from 1000 data points. And this dist plot has a parameter or argument that is kde, and this will be false. You don't need to think about it. We'll discuss when we will covering Seaborn library. So enter, and as you can see, we plotted this graph here between 4 and 5. Our beans are higher. These are beans. These beans are higher between 4 and 6. So it's mean that we got 4 and 6 more time than the other trials. So in that way you can also graph your trials of your binomial data distribution using SNS. Now, what is the difference between normal and binomial distribution? In the previous video, we have discussed that what is normal distribution, how to visualize it. And today we have discussed this binomial distribution. But what is the difference? So the main difference is that normal distribution is continuous. When you get that term, it will be continuous, whereas binomial is discrete. But if there are enough data points, it will be quite similar to normal distribution, and with certain LOC and scale and the mean and standard deviation that we have discussed already in the previous video. So let's graph both these functions, both this data distribution at the same time. So we have imported this random, matplotlib and Seaborn. After that we have used SNS, that is the Seaborn library, and it has a plot, it has a graph, that is dist plot. Within this we have first pass random dot normal, and the mean is 50, standard deviation is 5, and the data is 1000, and we have given label normal. Again we have plotted SNS dist plot, and we have passed binomial data distribution, and the number of trials that I want is 100, and the probability is 0.5, and the size is 1000, and the label is binomial. And after that I've just used plt.show, that is matplotlib function that will plot this graph. So as you can see, the first graph is a normal data distribution, and our mean is mostly existed between 45 and 50. This mean, as you can see right here, and we have discussed in the previous video. And the second graph is for this binomial data distribution, and we have 100 trials out of 1000, and our probability is 0.5, either for head or tail. Now here you can see that it is mostly higher between 50 and 55, so it means that we multiple times get 50, between 50 and 55 are trials. So that was all about binomial data distribution, and in the next coming videos of Numpy library we will do some advanced work. So see you there.